Hey stats class, when we are using a spreadsheet to do a confidence interval in chapter 7, we do a few more calculations than we need to do if we were using like a TI calculator, for instance. So if I use the TI, I can do this a lot quicker than what it's going to be if I use the spreadsheet. But if you want to use a spreadsheet, it's still not that bad. Technology does help speed things a lot. Okay, again, I like to label things. You don't have to label these, but it just helps keep things straight. If I'm going to use again, these spreadsheets have to be blank for the final exam. So I would label the things that I'm going to need here. So I need a sample mean, I need my sample standard deviation, I need my sample size, which is n, I need my confidence level, I need alpha over 2, right, because it's a confidence interval, and then I need my critical t. All right, these are given to me, the mean and standard deviation. There's the 12.7 is the mean. Standard deviation is the 16.6. And I don't know why it's around. Oh, yeah, I do. It's those up more decimal places. All right, n is 1004. All right, my confidence level is 99%. I'm going to write it as a decimal, 99%. Now, alpha is half of what remains when you subtract the confidence level from 1. So in math, that would, what I just said is equals 1 minus my confidence level. Click that, close that, divided by 2. All right, so alpha over 2 is what I need when I come up with this critical t value in a second. All right, I am going to, let me actually increase these decimal places just one more time because it's rounding these to too few places. All right, my critical t value, it's the number that is in the right tail that has this area to the right of it in a t distribution. So we get that from the t inverse calculation, the t dot inverse. And the probability, again, is the right tail, so I need to do 1 minus this alpha. So 1 minus, click that alpha, comma, and then the degrees of freedom is 1 less than the sample size. So the sample size is 1004, so the degrees of freedom is going to be 1003. Right? You can also click the sample size and subtract 1. That would be fine too. All right, so there's my t critical value. All right, and so now I have everything I need to compute the lower and upper number for the calculation. So I'm going to write lower and upper. All right, the lower number equals the sample mean, click that, minus the critical value times standard deviation divided by the square root SQRT of the sample size. All right, and that's what it always is. It's the sample mean minus the margin of error. The margin of error is that critical t times your standard deviation divided by the square root of your sample size. That's always your margin of error. All right, so there's my lower number. My upper number is the same thing except a plus in between the two instead of a minus. So sample mean this time plus critical number times standard deviation divided by SQRT, the square root of the sample size. Enter for that one. All right, and it says it wants these to 2 decimal places. So I'm going to select both of them. Use this button right here to get it down to just 2 places. All right, now once we do that, we've got the 2 numbers, but we still need to know the correct interpretation. So it's always going to be the one that talks about confidence. These are called confidence intervals. And you're confident the population parameter is in your interval. So I'm confident the population mean is in there. So I'm going to select B, and the lower number is the 11.35. The upper number is the 14.05. So there is my 99% confidence interval.